I think the main thing of this cruise was actually to bring different teams together, to have a holistic approach on studying the sea surface. And I think we accomplished that. I can't remember leaving a ship so happy and saying, yeah, we really did what we proposed, which is not always easy on the sea.
The long-term goal is to provide information that will help. I'm hoping that this data set will be, it's the first of its kind, where we're including the chemistry, the biology, and the physics of what's actually happening in the microlayer. And all these gas exchange measurements that we're making, all the microbiology measurements, these can be turned into basically equations that go into the model.
Even the latest models, they just ignore what happened at the sea surface. But we have to think that everything goes into the ocean or out of the ocean have to pass the sea surface microlayer, and therefore it should become a part of those computer models to improve forecasts of climate change.
And we've got some really interesting features, these slicks that we saw, which were heavy with cyanobacteria. So looking at the difference between the different environments and conditions that we've sampled in are going to be really interesting.
Just off the coast of Australia, when we saw this cyanobacteria trichodesmium blooms, the microlayer samples were highly enriched in those cyanobacteria. They appear to be living right at the very surface.
I was very surprised at just how much surface microlayer activity there is. We see how it affects the wave field, and it's very distinct from when there is no trichodesmium. It damps the waves, everything is much calmer.
I think the technology that's been used on this cruise has been really forward-thinking. The UAVs for me, I think, has been really cool.
You are good for launch. Roger, good for launch. Okay, lifting off in 3, 2, 1. Away from the ship, standing by for auto.
This aircraft is a hybrid system, so essentially it's a normal fixed-wing aircraft with a quadrotor attached to it.
Here we have our most exciting new platform for measuring the sea surface microlayer. We fly our instruments in this. There are 3 different types of instruments we're incorporating into the UAVs in this cruise: cameras, spectrometers, and radiation sensors. Once the UAVs take off, the instruments map both the ocean down below and the atmosphere above to acquire data that will help us understand processes affecting air-sea exchange.
During this expedition, we have a lot of instruments to study sea surface microlayer, and catamaran is one of them. This sea surface scanner uses a rotating glass plate that deep into the water. The oily microlayer sticks to them, and then 2 things can happen. Either the sample is run through a series of sensors that collect data about the water, or it is stored for later analysis. At the same time, the catamaran takes 1 meter deep water sample to compare it with the surface.
This is our in situ autonomous drifting buoy, and what it's measuring is the CO2 exchange from the ocean to the atmosphere. While the drifting buoy is floating around, its control unit is continuously taking air samples measuring carbon dioxide in the atmosphere. At the same time, it triggers pumps so that the floating chamber and the underwater CO2 sensor do the same. By correlating the partial pressure of CO2 in the air, surface and water, we are able to determine the velocity of the change of carbon dioxide between the atmosphere and the ocean.
One great thing about this study is it's really been a true collaborative effort. When we go back and look at our data, there's going to be a lot of effort to work together to understand not just our own data sets, but then how they interact.
We've gotten just about every sample we needed and more. But yeah, I mean, it's time to go home.